Oh, hey guys, how you doing? Man, I'm super excited. Last time we had a great time doing some physics together, and this reminds me, we're doing buoyancy. We're talking about buoyancy. Now, I had a definition for you last time, and it says buoyancy is the tendency for an object to float caused by upward forces. Now, it's also called Archimedes Principle. For those of my friends that are a little bit older, Archimedes Principle says the upward force on an object is equal to how much of the fluid that the object displaces. And we'll deal with that today a little bit more detail for my older scientist friends, but we're talking about buoyancy. We're having a great time. Now, we were talking about how things float, and so for example with this ball, if you remember from last time, we were talking about weight. The weight is pulling down on it, but the water's pushing up on it as a buoyant force. Buoyancy, and so in this case, this thing floats. Now, there are a lot of different things that we use. Remember old blue? Remember ping pong balls? They float. A cork, it floats. You have all kinds of different things we saw last time. Okay? We learned that like an eraser, it doesn't. And there's these different things that float and don't float. And so Miss Christy and I were looking at some things because we're doing experiments too, and we're trying to figure out how things work. And one of these things popped up at the very end of the last video. And so what we did was this. We took a spoon and a wooden spoon. We said that a spoon sinks, but a wooden spoon floats. And we learned that. And then I threw in a plastic one. Now this plastic one had a bunch of holes in it, and we learned very quickly that, whoops, it just starts to fall, and it slowly goes to the bottom. Now, what we're going to look at for a minute is something really different. This time, I got a plastic spoon like you eat with. Okay? So Miss Christy's going to come in real quick, and we're going to look at this one. This one's crazy. See if you can figure out this one. Now watch this. If I take this spoon and I drop it in there, it floats. That's pretty easy, right? Now watch what's going to happen this time. If I take this wooden spoon and I shove it to the bottom, it comes back to the top, right? What if I take that spoon and turn it upside down? It doesn't matter. But watch this plastic spoon. If I take this plastic spoon and I turn it sideways like that, it sank. So in some ways, it floats. But in other ways, it sinks. That's really what we're going to see with Archimedes Principle today. We're going to talk about that. That one's an awesome experiment. Now I'm going to pull these out real quick and just lay them here on the side because we're going to look at something different. Because there's a lot of different things that you could probably play with at home and try and see if they sink or float. So Miss Christy and I, we learned that we don't need goggles this time because we don't have any chemicals, but we're going to try some different things. And so we grabbed up an orange, okay? And so what we're going to do is a couple things. We're going to deal with some citrus fruits, things that we eat. Now watch this. Do you think it sinks or floats? Let's see. Oh, it floats pretty easily, okay? You can see that pretty good. It floats, okay? Now, this is a lime, okay? Sink or float? Ha-ha! I don't know. Whoop, it's trying. What's it doing? Oh, it floats also, okay? It floats. Now, this one's a little bit different kind of orange. This one's called a blood orange. Okay, most of you have eaten an orange before, but a blood orange it's sort of red on the inside. You'll see it here in a minute. But I drop that in water, they float. And these were the things I happen to have. Okay? Now here's an interesting one. Here's a grape. All right? Everything floats. Oh, that didn't float, Miss Christy. That one didn't float. Matter of fact, look at that lime. It's doing some weird stuff. Okay? A while ago, it was floating really good. Now, if I take it and drop it back in, I'm going to try again. Okay? It was floating a little bit off the bottom. That's interesting. See it? Look at changing. Wow, it's somewhere in between. It's heavy enough, and that pushing up is not just enough to get it there. It's trying. So this one's really floating on top. That's sort of in the middle. That's cool. I bet you can find some other stuff that does that too. But I'm going to do something really different. I'm going to take this orange out. And we had two of those blood oranges. Actually, I'm going to start with the lime. And we took another lime. We had two limes, and Miss Christy peeled it for me. And so if I take the peeling off, what do you think happens? Well, it's still all in one piece. Did I take off very much? No, it's just the outside. And if you've ever peeled a lime, it's pretty thin. So what do you think happens? Sinks or floats? Well, we see what's happening there. Let's see what happens here. Give it just a second. Man, it's really touching the bottom. It's below where the lime was. Okay, so which one's floating better? The one with the peel on it. Not a lot better, but the one with the peel on it. So we also had 2 blood oranges. And so we took 1 blood orange, and then we took another blood orange, and we took the peel off of it. Now you'll see in that blood orange, some of you haven't seen that before, it's really dark, okay? So when you eat it, it tastes like an orange, but it's on the inside, it's sort of a reddish color. When I'm done with it in a minute, I'll open it up so you can see it. When you drop it in water, what do you think is going to happen this time? Sink or float? Huh, they both float. So those 2, the lime was doing something different, but the blood orange is doing the same thing. Now, this one was a navel orange. So what I'm going to do with this navel orange, what did we find out with that one? It floats real easy. Now, I had to borrow this from my neighbor. I was out of them. Some of you eat these things called cuties. And so what I'm going to do real quick is I'm going to take that. I'm going to take a knife real quick to help me. I'm going to take that peel off. And we're going to see what happens when I take the peel off. Now, when you go along and do this, there it goes. Just going to take all that peel off. That floated really good, didn't it? Ooh, I love the smell of oranges when you take the peel off. That smells, oh, I'm supposed to do something with it. Woo, that smells really good. I like it. And as a matter of fact, if you're in one of the other videos, we talked about how these oranges come from plants, don't they? Remember that? Did you see that video with me? How we talked about how fruit plants make fruit? Oh, it's cool. Comes from the ovary of the flower. It's really cool. So we have that orange, and I took the peel off. Remember, what did this orange, this navel orange do? Floated. What happens when I peel it? It sinks. Huh. 3 different things happened. In a blood orange, they did the same thing. In a lime, when the peel was off, it sank a little bit lower than this lime. Yeah, it's floating a little bit different. You can see it better now, and it's moving around because there's a little bit of waves going on. And so you can see it. Thank you, Miss Christie. That's a great angle right there. You can see what's going on. But then the orange, the navel orange, was completely different. The orange itself floated real easy, but when I took off the peel, it sank. Here's the difference. I want you to check out the peel. I want you to see, Miss Christie's going to have to come in close. I want you to see the peel of a lime. Now you see all those dark green dots on there? All those dark green dots, they're little pockets of air that are built into the peel. Now, I'm going to see if I can do this. I have to do it better with the orange. On an orange, I'm going to be real still for a second. If you look in the edge of this orange right here, you can see the little pockets of air right there. And so those pockets of air are sort of like a floaty on somebody learning to swim. And so it helps it be more buoyant and it floats. But when you take it off, what happens? It sinks. You take a small child that doesn't know how to swim, you put floaties on them, they can float around the water and do stuff. But if they take their floaties off, what's going to happen? They're going to go to the bottom. Why? They don't know how to swim. And so for that last orange, I took all that peel off. And it's all, if all the peel has lots and lots of little air pockets built in, and they're tiny, they're really hard to see, you got to really look at it. But when you take that off, it doesn't float like it's supposed to. So it's heavy enough that it sinks, okay? The buoyant force is trying. Remember this from the last video? But it sinks. Now, we have our little friend, the grape there. He's doing something really different. Man, he went straight to the bottom, right? Now, you can try this at home. When you have a grape, drop a grape in there. And then what I want you to do next time is I want you to take it and take the peel off and see, does it sink or float? That's your experiment. Find out what happens. But that grape went to the bottom. But I'm going to do something really cool with it. Really, really cool with a grape. So what we're going to do is I'm going to take that grape. Come here, grape. You're all wet. That's okay. I'm going to take that grape and I'm going to move these peels real quick, and we're going to do another little experiment real quick. And what I'm going to do is I'm going to take a couple of glasses. Okay? Now I have them, these happen to be green because this is what I have at my house. But what we're going to do is I'm going to take some water, put some water in there, okay? And I'm going to give it actually a little bit more than that. Oh yeah, that's awesome. That's water. And then I'm going to take this bottle solution here for a minute. I'll put that one in there. Now check out what's happening when I pour it in there. Okay? It's got carbonation in it. Okay? It's got carbonation in it. Now, carbonation is the bubble that makes Cokes and things like that taste really good. And so what I'm going to do is I'm going to do something a little bit different. I'm going to take my knife that I had and I'm going to take a grape. I'm going to just cut it in half. 2 halves of a grape. Okay? Now, I'm also going to have some other friends join in. And some of you at your house probably have like raisins. Now, raisins, or you have Raisin brand cereal that has raisins in it. At my house, we had some craisins. Okay? They were cranberries that are dried out. So what is a raisin? A raisin is a grape that they dried out. Most of the liquid's gone. It's a raisin. They just give it another name. This is a cranberry, and it has shrunk up. It's called a craisin. Okay, so I'm going to have one that goes in this cup, and I have another craisin that's going to go over here. And then I have little pieces of rice. Okay, and I'm going to put some of the rice, and so here we go, in the water. There they go. That guy goes in there. That guy goes in there. Check out what they're doing. Okay, and I'm going to throw the same things into the other side. Okay, I'm going to drop those into that Sprite solution. Now we're going to focus on this one first, okay, as Miss Christie gets close. What did the grape do? The grape went straight to the bottom. Now that craisin is down there next to it. Do you see it down there? Yeah, I see it. I see it. It sank. Now, this is not the exact rice I wanted to have. This is an instant rice. Probably you have more of a dried out rice, but this will work. Takes a minute. It's going to have to absorb some water, but it's floating right now. So I have things that are floating, and I have things that are sinking. Now I want you to check out what's happening over here. Check that out. Oh, look at them. They're going up and down. Look at that craisin. You know what? I have another one here. Get in there. Okay, he went to the bottom. Watch what happens when he hits the bottom. There's bubbles. Do you see those bubbles, Miss Christie? Can you see that all right? Oh, that's awesome. Now watch that craisin on the bottom right there. He's going to get bubbles on him, and then all of a sudden, he's going to rise to the top. Whoa, look at that grape go down. And so what happens is that grape and that craisin, they get gas bubbles that collect on them. And so what happens is, what happens if you have a helium balloon? It tries to rise. Oh, there it went. Yeah. Okay, it'll do it again. And so if you have a helium balloon, it always floats, right? Why? It's trying to go up. And so as it gets that gas on it, and it's carbon dioxide gas that's in there, that's what makes it taste so good. And so they're going up and down and up and down. Now we're going to have to wait on the rice for a minute, because again, they have to get a little bit wet. So I'm going to make a little bit of bubbles. Oh, did you notice when I hit them, they fell to the bottom? Now watch what happens. It floats to the top, and it goes back down. Why does it go back down? As soon as it gets to the top and the bubbles come off of it, it's now too heavy and it sinks. And so that buoyant force is still trying to push it up. It's the same thing we saw in everything we've been doing. But I'm breaking the rules by letting gases stick to it. And so it goes up and down and up and down. This one is really cool. This one's cool. You want to try this at home. Now, you can do it in any kind of soda that you want. I chose one that was clear so you could see it through the glass. But any of them work. If they're not very dark, you can watch them go up and down and up and down. So you can do it with a raisin. You can try even other things that I didn't try. Now, if the rice starts doing what I want it to do here in a minute, I'm gonna make sure you see it. But I'm gonna let those go up and down and up and down. But you may be thinking, hey, at my house, we don't have a soda that's clear like that. Well, I have a way around it. So I'm gonna take a third glass real quick. And here's what I'm gonna do. I'm gonna make my own carbon dioxide gas. Check this out. If you've done some videos with me, you've seen these things, baking soda and vinegar. What happens when you put those dudes together? It bubbles, okay? And so what I'm gonna do is I'm gonna take a little bit of water. Come here, water. Yeah, just like that. I got some water, okay? And then what I'm gonna do is I'm gonna take some baking soda and I'm gonna put it in the bottom. When it goes down to the bottom, I'm gonna mix it up just a little bit. Mix, 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 mix. Great. What do I have right now? I have baking soda and water. That's it. But I'm going to cause a reaction. Now, so I don't get in trouble, I'm going to put it in a bowl. Because I just thought about this, and I know what's going to happen. So I'm going to take a bowl, and I'm going to make a reaction. That means I need my goggles. Okay. I'm ready. Miss Christie reminded me. Okay, so we're going to have a reaction that happens. So I'm going to take my vinegar and I'm going to pour it in there. Watch what happens. Crazy bubbles. Now, that's why I have the bowl. That's a cool reaction. I still like it. Now, check out what's happening inside the cup. I have bubbles now, don't I? So I have some gas in there. By the way, did I use it all? I'm just going to put a little bit more. Yep, see it start bubbling again? I don't want too much where it comes over the top. So I'm going to do the same reaction. Check it out. I'm going to take a half a grape and I'm going to drop that in there. And watch what happens, okay? Here it goes. There it goes up. And watch. It's going to sit there for a second, and then it's going to fall again. And it's going to go up and down and up and down. And so I'm going to take my goggles off because I'm done with the reaction. And so it's got so much gas in there, it doesn't even want to fall, okay? Doesn't even want to fall. As a matter of fact, watch this. I'm going to reach in here, and I'm going to grab this Raisin now, this one that was just water. And I'm going to drop that dude in there. Ready? Whoop! There he goes. He's in the bottom. Now I see bubbles all over him. Come on. Magic. Rise! Come on. You can do it. Yeah. Do you see that? You could almost do like a magic trick for your parents. That was awesome. And so if I want it to go to the bottom, all I got to do is touch it, and it'll fall back to the bottom, and it'll do it over and over and over. If you put the rice in there, what you're going to find, if you have a little bit better rice than I do, I'm going to throw those two in there and see if I can make them do it and really get them really, really wet. What's going to happen is they almost dance in the water. They go up really, really fast. And so I just didn't have the right kind of rice. But if you do, you can make them go up and down and up and down and up and down. So what did we find? We found that in water, it didn't do that. But if I had bubbles, I can change the force. I can fight gravity and make it buoyant, whoop, and then it falls. And then up, and then down, over and over and over. So what did we find so far? You can take citrus fruits, and some of them float and some don't. Hey, try out some others that I don't have. Try it out. See how it works. That's what I did. As a matter of fact, Miss Chrissy and I didn't even know what that navel orange was going to do. We just got it. And it worked awesome. Try out your own. You get a good picture, put it down in the comments. I'd love to see it. Now, I'm going to do one more thing, and this one's really, really awesome. And I'm going to leave these other things bouncing around as I need to. And so I'm going to move them all over here for a minute. And so what we're going to do is we're going to make something, kids. This is something that you can make at your house. Now, this one's easy. You need a piece of foil, okay? You're going to need two pieces of foil, actually. And so you're going to do an experiment, okay? And here's how it's going to work. I'm going to take 10 pennies on a piece of foil, okay? So it's just 10 pennies. And I have another one that matches it, so I'm going to do an experiment, okay? Now, in an experiment, hey, real quick for you, check out my shirt. This is my shout out for my seniors at my school, okay? I know we're not in school right now. Shout out from Mr. Patrick's Laboratory to the seniors at my school. Excited for you guys. Great things coming. But in our experiment, here's what we're going to do. My seniors know this, that whenever you do an experiment, you have a control, and then you're going to test something. So here's what we're going to do. We're going to take this piece of foil, and all I did was, it is 12 inches across. So all we did was we cut it in half, and we made it 8 inches long. It doesn't really matter your dimensions, but this is what I did. I have 10 pennies. We're going to try two different things. I'm going to take those 10 pennies, and I'm going to wad them up into that piece of foil. All right, backing up just a little bit. Here we go, Miss Chrissy. Now, foil is a metal. The pennies are made of copper and zinc. Sink or float? Well, do you think it's going to do like this? Let's see. Here we go. Well, that was pretty easy. Is it going to come back up? Nope. It's so heavy, it just sinks. The buoyant force couldn't keep it up. Now, how can we fight that? I got an idea. Whenever I go swimming, okay, and this is Archimedes Principle. When I go swimming and I'm swimming in the pool and I lay on my back, I can stretch out and I can float. But if I pull my arms and legs into a ball like that, I go underwater. So when I lay out flat, I can float. But when I pull all of that in, I sink. Check it out. Here's what I'm going to do. I'm going to take this piece of foil, and I'm going to fold the corners in. Okay, I'm going to take all four corners. I'm going to fold them in. And then I'm going to make walls. Okay? Make walls that look like this. Pull up a wall on this side. I'm going to make an aluminum boat. Okay? So I'm going to bring that in, and notice how I just pinched those edges together. Just folded it in. See how I made a wall? Okay? Bring this up. I'm going to bring this up. Come on, stand up for me. There it goes. I'm just going to pinch these walls together because aluminum foil does that real easy. Okay? Then I'm going to bring this side up. Now, it's the same exact size of the other piece of aluminum foil. And I did it really quick. It's not the best ever, but it'll work. Squeezing the sides together, squeeze the sides together. There it is. Now, watch what happens. I'm going to take my aluminum boat. Boom! There it is. That's awesome. Now, it's right above the other one, so check that out. It's right above it. Okay, so I have aluminum on top and aluminum on the bottom, but what's the difference? That one's full of pennies. So if I'm going to do the experiment, I got to do this one the same way. So here's my 10 pennies. Check it out. 1 penny, 2 pennies, 3, 4, 5, 6, 7, 8, 9, 10. Check it out. It sank. No, it didn't. It's floating. Check that out. It's floating. It's like a boat. I made a raft and it's floating. So why is it doing that? What's happening? Here's what's happening. It's Archimedes Principle, and it says the upward force on an object, my boat, is equal to how much of the fluid, how much of the water, that the object displaces. So displaces means pushes out of the way. So if I have a ball that's this big around, or a piece of foil that's this big around, which one pushes on more water? This one. And so it's pushing in all directions. And so the buoyant force is pushing up on all of the bottom of the boat, and it's holding it up. So here's what you get to do, kids. You make a boat just like I did. I put 10 pennies. It's not anywhere close. How many pennies can you put in there before it sinks? Will it ever sink? I don't know. Why? It's an experiment. And if it does, take a picture before and after, and then print. Tell me, how many pennies did it make for you to sink your boat, if you could sink it? So do all the same coin. Don't do quarters, nickels, and dimes. Just pennies. Keep putting pennies until it sinks, if it sinks. Why? Because it's science, and you get to do it yourself. And science says that you can try it, and I bet you're great at it. So today we did buoyant forces. In the next video, we're going to have a great time with water, and we're going to make a submarine. So after this video is done today, I'm going to post all the things you need, and we're going to make a submarine. It's an awesome time. We'll see you next time on Mr. Patrick's Laboratory. We're having a great time. Hope you are too.